I am Carla Joyce Puno and I will be discussing Chapter 9.3, Testing the Difference Between Two Means, Dependent Samples. In Section 9-2, the t-test was used to compare two sample means when the samples were independent. In this section, Chapter 9.3, a different version of the t-test is explained. This version is used when the samples are dependent. Samples are considered to be dependent samples when the subjects are paired or matched in some way. What is the difference between independent samples and dependent samples? Independent samples occur when you have two samples that do not affect one another. On the other hand, the dependent samples occur when you have two samples that do affect one another. Dependent samples are paired measurements for one set of items, and the independent samples are measurements made on two different sets of items. So when you conduct a hypothesis test using two random samples, you must choose the type of test based on whether the samples are dependent or independent. It is important to know whether your samples are dependent or independent. If the values in one sample affect the values in the other sample, then the samples are dependent. If the values in one sample reveal no information about those of the other sample, then the samples are independent. So as you can see on the picture, the dependent samples, the individuals are related, and the sample sizes must be the same. And the independent samples, individuals are not related, and the sample sizes may not be the same. Sa dependent samples is meron silang relation, is connected yung mga samples natin. Sa independent naman is wala silang relation with each other. Following are some examples of dependent samples. So our first example, suppose a medical researcher wants to see whether a drug will affect the reaction time of its users. To see this hypothesis, the researcher must pre-test the subjects in the sample first. That is, they are given a test to ascertain their normal reaction times. Then, after taking the drug, the subjects are tested again using a post-test. So, yung researcher is itetest muna yung mga samples para sa pre-test niya. And then, pagkabigay ng drugs, is itetest ulit niya yung mga samples for the post-test. So, the means of the two tests are compared to see whether there is a difference. Since the same subjects are used in both cases, the samples are related. So, they are dependent samples. A researcher may want to design a school ability test or SAT preparation course to help students raise their test scores the second time they take the SAT. So, meron ulit siyang pre-test and post-test. Kasi sabi niya is preparation to help the students for the second time they take the SAT. Hence, the differences between the two exams are compared. Our next example, a medical specialist may want to see whether a new counseling program will help students lose weight. Therefore, the pre-weights of the subjects will be compared with the post-weights. So, titignan daw nung medical specialist if yung bago nilang program is makaka-help sa students or sa mga subjects nila to lose weight. So, meron ulit siyang pre-test and post-test between sa same samples. Dependent samples is usually makikita natin siya or madidetermine natin siya na dependent sample siya is kapag ginagamit siya as a pre-test and post-test. So when the samples are dependent, a special t-test for dependent means is used. This test employs the difference in values of the matched pairs. The hypotheses are as follows. We have two-tailed, left-tailed, and right-tailed. Nandyan pa rin yung null hypothesis natin and yung alternative hypothesis. But, yung gamit nating sign is mu sub d, wherein this symbol is which is the expected mean of the difference of the matched pairs. So as you can see, we have here the procedure table of the traditional method in solving hypothesis testing problems. It consists of 5 steps. We have state the hypothesis and identify the claim. Find the critical values from the appropriate table in Appendix C. Compute the test value. Make that decision to reject or not reject the null hypothesis. And last is to summarize the results. Diba yung sa step 3, compute the test value is usually z-test or p-value yung kino-compute natin. But for this chapter 9.3, we have this procedure table. Since we are testing the difference between means for dependent samples. Meron pa rin tayong hanggang step 5, katulad ng traditional method. But here, for the step 3, when in computing the test value, meron pa tayong 6 steps. We have A, B, C, D, and E, and F. So, on step A, gagawa tayo ng table. As you can see on our picture, gagawa tayo ng table, and then sa next step is magko-compute na tayo. We complete the table. And then hanggang 6th step is yun na yung final step to find the test value. Is the general procedure for finding the test value for our step 3 procedure. We have first step 1. First, find the differences of the values of the pairs of data. We have this formula, d equals x sub 1 minus x sub 2. Step 2. Find the mean of the differences using the formula. We have d bar equals summation of d over n, where n is the number of data pairs. Step 3. Find the standard deviation of the differences using the formula given. Next step, step 4. Find the estimated standard error of the differences. We have this formula, S sub d bar equals S sub d or yung standard deviation of differences over square root of n. Step 5. Find the test value using the formula given. And step 6. The formula in the final step follows the basic format of test value equals observed value minus expected value all over standard error, where the observed value is the mean of the differences. The expected value mu sub d is 0 if the hypothesis is 0. The standard error of the difference is the standard deviation of the difference divided by the square root of the sample size. And both populations must be normally or approximately normally distributed. Again, for our step 3, we have this general procedure for finding the test value. We have 6 steps. First is the differences of the values of the pairs of data. Second, mean of the differences. Third, standard deviation of the differences. Fourth is estimated standard error of the differences. And then fifth is the test value, and our next is the final step. So we have this guide table. We have this first column for our symbol, and the next column is for its description. N is the number of pairs of data. D, the difference between entries for a data pair. We have the formula D equals x sub 1 minus x sub 2. Next, mu sub D is the hypothesized mean of the differences of paired data in population. D bar, the mean of the differences between the paired data entries in the dependent samples. We have D bar equals summation of D all over N. The next, S sub D, the standard deviation of the differences between the paired data entries in the dependent samples. We have this formula. And then the observed value is the mean of the differences. The expected value, mu sub D, is 0 if the hypothesis is mu sub D equals 0. Standard error of the difference is the standard deviation of the difference divided by the square root of the sample size. So let us have an example. Example 9-6. Vitamin for increased strength. A physical education director claims by taking a special vitamin, a weightlifter can increase his strength. 8 athletes are selected and given a test of strength using the standard bench press. After 2 weeks of regular training, supplemented with the vitamin, they are tested again. Test the effectiveness of the vitamin regimen at alpha 0.05. Each value in this data represents the maximum number of pounds the athlete can bench press. Assume that the value is approximately normally distributed. And we have this given table. We have 8 athletes and we have the before and after. So, if we observe our problem, gumamit siya ng pre-test and post-test para sa mga sample na athletes. So, it is a dependent sample. So, step 1. State the hypothesis and identify the claim. For the null hypothesis, we have age sub 0, our mu sub d or the mean of difference is equal to 0. And we have the alternative hypothesis, we have age sub 1, our mu sub d or mean of difference is less than 0. This is the claim of our problem, our alternative hypothesis, and it is a left-tailed test. Since nakasabi sa problem natin, it claims by taking a special vitamin, a weightlifter can increase his strength. Pero, bakit less than yung ginamit nating sign? At naging left-tailed test siya. Since we are interested to see if there has been an increase in their strength, the weight they lifted before taking the special vitamins must be less than the weight they can lift now. Hence, the differences must be significantly less than before than they are now. For the vitamin to be effective, the before weights must be significantly less than the after weights. Hence, the mean of the difference must be less than 0. So, para makita yung effectiveness ng special vitamins is yung weight na nabubuhat nila sa before is dapat mababa siya kumpara sa mga weight na mabubuhat nila for the present or after taking the vitamin. So, our claim is our alternative hypothesis. Our age sub 1, our mu sub d or mean of the difference must be less than 0. Step 2. For our step 2, we find the critical value. So we have 8 athletes, so our n or our sample is equal to 8. So our degrees of freedom, we have df n minus 1, which is equal to 8 minus 1, which is 7. Our degrees of freedom is 7. The critical value for a left-tailed test with alpha 0.05, we are going to look for the critical value of alpha and for our degrees of freedom on the t-distribution table for our critical value. So we have this t-distribution table, our table F. For our given problem, we have left-tailed test. It is only one tail, and with alpha 0.05 and degrees of freedom 7. So our critical value based on our table is 1.895. Since our test is left-tailed test, our critical value will be negative. Our critical value now is negative 1.895. So next, step 3, compute the test value. Ito na yung part wherein meron pa siyang another 6 steps. Ito yung mga steps to compute our test value. So step A, make a table. So gagawa tayong table based sa given table natin sa problem. Yung may athlete before x sub 1, after x sub 2. So this is our table. And then next, ilalagay natin sa table yung before x sub 1 na values and after x sub 2 na values. Ayan. So, next, find the differences and place the results in column A. So, ayan na yung step 1 natin is gagamitan na natin siya ng formula. For our column A, we have D equals x sub 1 minus x sub 2. Wherein, ima-minus natin yung value na x sub 1 sa x sub 2. And then, ilalagay natin sa column A. So, for column A, again, x sub 1 minus x sub 2. We have 210 minus 219 is equal to negative 9. 230 minus 236 is negative 6. 182 minus 179 is positive 3. 205 minus 204 is positive 1. 262 minus 270 is negative 8. 253 minus 250 is positive 3. 219 minus 222 is negative 3. 216 minus 216 is 0. And we add all the values in our letter A, which is the D equals x sub 1 minus x sub 2. So we have the summation of D equals negative 19. Then next, for our step C, find the mean of the differences. We have this formula, D bar equals summation of D divided by N. Our N is 8 and our summation of D is negative 19. So we have negative 19 over 8. Negative 19 divided by 8 is negative 2.375. This will be our mean of differences. So next step, square the differences and place the results in column B. For the column B, we squared the value that we got for our column A. We squared the value D. So we have negative 9 squared is 81. Negative 6 squared is 36. 3 squared is 9. 1 squared is 1. Negative 8 squared is 64. 3 squared is 9. Negative 3 squared is 9. 0 squared is 0. Then, we add all the values for our column B. We have the summation of d squared is equal to 209. So we have completed the table. Next step, step E. Find the standard deviation of the differences. So we have this formula. S sub d equals the square root of n times the summation of d squared minus the square root of summation of d all over n quantity n minus 1. So we have the value of n, which is 8, and the summation of d is negative 19, and the summation of d squared is 209. So we substitute our values. Now we have square root of 8 times 209 minus the square root of negative 19, all over 8 quantity 8 minus 1. Now we solve. We have the square root of 1672 minus 361 over 56. So our value for the standard deviation of the differences is 4.84. So next step, find the estimated standard error of the differences. We have this formula. S sub d bar equals S sub d, or the standard deviation of the differences, over the square root of n, where n is 8 and our S sub d is 4.84. So we substitute. We have 4.84 over the square root of 8. And now the value of the estimated standard error of the differences is 1.71. Step, find the test value. We have this formula. T equals d bar minus mu sub d all over S sub d over the square root of n. So we substitute our values. We have negative 2.375 minus 0 all over 4.84 over the square root of 8. Now we have negative 2.375 over 1.71. And our test value is negative 1.388. And then, for the last step, we have this sixth step. We have this formula. Test value equals observed value minus expected value all over the standard error, wherein the observed value is the mean of the differences, or the d bar. And then the expected value is the mu sub d. It is equal to 0 if the hypothesis is mu sub d equals 0. And then the standard error of the difference is the standard deviation of the difference divided by the square root of the sample size. This is the S sub d bar. So we have this formula. Test value equals d bar minus mu sub d over S sub d bar. Then we substitute our given values. We have negative 2.375 minus 0 all over 1.71. Then this is now our test value. We have negative 1.388. So our answer for the step 6 is just the same with the step 5. And now, we proceed on the next step, step 4, make the decision. We plot the test value and the critical value. And these are the values that we got from the step 3. We have the critical value of negative 1.895 and the test value is negative 1.388. And this is our curve. And this part is the non-critical region, or do not reject region. And our test value is negative 1.388. And our critical region, or the reject region, is negative 1.895. And since our test value falls on the do not reject region, or the non-critical region, the decision is not to reject the null hypothesis, at alpha 0.05 since negative 1.388 or our test value is greater than our critical value which is negative 1.895. So last step, we have the step 5, summarize the results. There is not enough evidence to support the claim that the vitamin increases the strength of weightlifters. To answer the problem on example 9-6, we use all the 6 steps for finding the test value. Hence, in our module, they did not use all the 6 steps, but in the end, we came up with the same answer. In our module, the formulas that were used for this t-test in example 9-6 are the following. These are the main formulas for the t-test for dependent samples. We have the formula of t, or the test value, equals d bar minus mu sub d, or the mean of the differences, over standard deviation of the differences over the square root of n, with degrees of freedom n minus 1, and where the d bar is the summation of d over n and the standard deviation of the differences. We have this formula. So next example, we have example 9-7, cholesterol levels. A dietitian wishes to see if a person's cholesterol level will change if the diet is supplemented by a certain mineral. 6 subjects was pre-test, and then they took the mineral supplement for a 6-week period. The results are shown in the table. Cholesterol level is measured in milligrams per deciliter. Can it be concluded that the cholesterol level has been changed at alpha equals 0.10? Assume that the variable is approximately normally distributed. And we have this given table. We have our subject and our before x sub 1 and after x sub 2. So for our step 1, state the hypothesis and identify the claim. So our null hypothesis is age sub 0. Our mu sub d, or mean of the differences, is equal to 0. And our alternative hypothesis is age sub 1. Our mu sub d, or mean of the differences, is not equal to 0, which is the claim in our problem. It is a two-tailed test kasi tinitignan kung magbabago ba. Ayan, if the diet is effective, the before cholesterol levels should be different from the after levels. So next step, step 2, find the critical value. So our n is 6 since we have 6 subjects. Our degrees of freedom, df, n minus 1 is 6 minus 1 is equal to 5. So our degrees of freedom is 5. So the critical value of a two-tailed test with alpha 0.10, we're going to look for the critical value of alpha on the t-distribution table. We have the table F for the t-distribution table. We have in our given problem, we have two-tailed test with alpha 0.10 and with a degrees of freedom 5. So our critical value is 2.015, 2.015. So it will be positive and negative 2.015 since our problem is two-tailed test. So next, step 3, compute the test value. Our step A, make a table. This is our table and we list all the given values in our table. We have the before x sub 1 and we have our after x sub 2. And then next, step B, find the differences and place the results in column A. For the column A, we have the formula D equals x sub 1 minus x sub 2, wherein we subtract the value of before and after. We have 210 minus 190 equals 20. 235 minus 170 is 65. 208 minus 210 is negative 2. 190 minus 188 is 2. 172 minus 173 is negative 1. 244 minus 228 is 16. And then we add all our values in our column A, the values of D. We have summation of D equals 100. And then next, step C, find the mean of differences. We have the formula D bar equals summation of D over N, wherein our summation of D is 100 and our N is 6. Then we divide 100 divided by 6 is 16.7. This will be our value for the mean of differences. Next step is square the differences and place the results in column B. For the column B, we squared the value that we got for our column A. We have D squared. We have 20 squared is 400. 65 squared is 4,225. Negative 2 squared is 4. 2 squared is 4. Negative 1 squared is 1. 16 squared is 256. And then we add all our values in our column B. We have the summation of D squared is equal to 4,890. We have completed the table. And then next step, step E, find the standard deviation of the differences. We have this formula, S sub D equals the square root of N times the summation of D squared minus the square root of the summation of D all over N quantity N minus 1. The value for our N is 6. And for our summation of D is 100. And for our summation of D squared is 4,890. And now we substitute our values in our formula. We have the square root of 6 times 4,890 minus 100 squared all over 6 quantity 6 minus 1. Now we have a square root of 29,340 minus 10,000 all over 30. Now we have the value of the standard deviation is equal to 25.4. And the next step, step F, find the test value. We have this formula, T equals D bar minus mu sub D over S sub D, or the standard deviation of the differences, over the square root of N. And then we substitute our values. We have 16.7 minus 0 all over 25.4 over the square root of 6. Now we have the value for our test value, which is equal to 1.610. And then, next step, step 4, make the decision. We plot the critical value and the test value that we got from step 3. Our critical value is positive and negative 2.015 since our test is two-tailed test and our test value is 1.610. This is our curve. Our critical values are positive and negative 2.015 and our test value is 1.610. And the test value falls on the non-critical region which is the do not reject region. And the decision is to not reject the null hypothesis, since the test value 1.610 is in the non-critical region. So last step, step 5, summarize the results. There is not enough evidence to support the claim that the mineral changes a person's cholesterol level. Again, we have this procedure table for the testing the difference between means for dependent samples. Since we finished answering our examples for the testing the difference between means for dependent samples, we now have the confidence interval for the mean difference. We are going to compute for the confidence interval for the previous example, which is example 9-7. We have this formula for the confidence interval for the mean difference. So, this will be our example 9-8. We find the 90% confidence interval for the data in example 9-7. And these are the data or the values from the previous example, example 9-7. We have the D degrees of freedom 5 and the D bar is 16.7 and the S sub D is 25.4 and the test value is 1.610. And we have in our given problem is 90% confidence interval. So we look for the T sub alpha over 2. So we have 90% and a degrees of freedom of 5. So we look at the table F for the T distribution table. We look for the 90% and for the degrees of freedom 5, and their intersection is 2.015. Therefore, our T sub alpha over 2 is 2.015. Then, we have now completed our values. Now we substitute our values on our formula. We have 16.7 minus 2.015 times 25.4 over the square root of 6. And for the right side, we have 16.7 plus 2.015 times 25.4 over the square root of 6. Now we solve. And now for the value of the mean difference, mu sub d, we have greater than negative 4.19 but less than 37.59. Since the 0 is contained in the interval mu sub d is greater than negative 4.19 and less than 37.59, the decision is to not reject the null hypothesis. Since our null hypothesis H sub 0, mu sub d is 0. That will be all for the chapter 9.3. Thank you for listening.